Welcome back to the N25 Marks walkthrough. This is Andrew, and we are doing paper 1. This is question 4. In part A, you are asked to prove a trig identity, and in part B, you are asked to use it to solve the equation. So let's start with part A. This is a relatively straightforward proof. You can choose to start with the left-hand side or the right-hand side. I would personally go with the right-hand side. So, sine of 3x minus sine of x. The reason why I decided to go with this is because I know that I will have to split the 3x into 2x plus x. Sine of a plus b. This formula can be found in your formula booklet if you happen to have a brain freeze. However, you should have it memorized by now. So sine of 2x plus x, sine of a plus b is sine a cos of b plus sine b cos of a minus sine of x. We know that we have sine of x as a factor. A simple way for us to get to the left-hand side is finding a way to get sine x out as a factor. We have sine x here, we have sine x there. We know that sine of 2x is 2 sine x cos x. Now we can factor the sine x out. What's left is 2 cosine squared plus cos of 2x minus 1. This is a show that question. Please take your time and make your reasoning crystal clear. Examiners will be on the lookout for fudging. If any of your steps looks suspicious, you will lose a mark. 2 cos squared minus 1. This is another cos of 2x. And therefore, you have your 2 cos 2x sine of x as requested. In part B, notice the word hence. You have to use the result. We have sine of 3x minus sine of x from part A. So why don't we subtract sine of x from both sides? This term is equal to 2 cos of 2x sine of x. Sine of 2x, that's 2 sine x cos x. We can now factor out this 2 sine of x. And you're left with cos of 2x plus cos of x. From this point, there are many ways to solve this equation. I'm going to solve it in the simplest way. Cos of 2x is 2 cos squared minus 1. Now we have two equations that you should all know how to solve. Sine of x is equal to 0, or 2 cos squared plus cos minus 1 is equal to 0. Sine of x is equal to 0 if x is 0, pi, or 2 pi. Scrolling up, always pay attention to the domain. Two questions you should ask yourself. 1. Are the endpoints included? 2. Is it in radians or degrees? If they give you the interval in degrees, but you give your answers in radians, you will lose a mark. And vice versa. If they give you in radians and you give your answers in degrees, you will lose a mark. On the right hand side, 2 cos squared plus cos minus 1. Factorize this guy. you should get cos x plus 1 to cos x minus 1. So cos x is equal to negative 1, or cos of x is equal to 1 by 2. There are various ways to solve this equation. Personally, I prefer to sketch the function out. You can also use the unit circle. Whatever works for you. Cos x equals to negative 1 occurs when x is equal to pi. Cos of x equals to 1 by 2 occurs when x is equal to 2 pi by 3 or 5 pi by 3. Do we have to take periodicity into account? In this case, no, because the period of the function is 2 pi, and our interval is from 0 to 2 pi, so we don't need to add any multiple of the period. Therefore, your solution set is 0, pi by 3, pi, 5 pi by 3, 2 pi. This is the end of question 4. Question 5. This question is on normal distribution. At first glance, this question is very scary. So if you're not confident with your distributions, please skip ahead. Pause the video and have a go at it if you can. Good. So now we are going to tackle this. You're given two pieces of information about x and y. We are given that p of x less than 13 is equal to 0.7. We are given that p of y less than m, given that y is greater than 20, is 0.4. We are also given the mean and the standard deviation of the two distributions. How can we link the two? We can link the two via normalization. In other words, obtaining the z-score for the values that we are given. So, let's normalize the first guy. For x, we know that x has a mean of 10 and standard deviation sigma. So normalizing 13, we should get z less than 13 minus 10 divided by sigma is equal to 0.7. Or p of z less than 3 divided by sigma is 0.7. On the right hand side, we have a conditional probability. It always helps to sketch the distribution out. This is why. It has a mean of 20, and let's say m is over here, and we're given that the probability that y is less than m, given that it's greater than 20, is 0.4. Let's undo this notation. This is equal to the probability that y is between 20 and m, given that it is greater than 20, is equal to 0.4. The probability that y is greater than 20 is 0.5. Thus, p that y is between 20 and m is 0.2. We also know that the probability that y is less than 20 is 0.5. Thus, the probability that y is less than m is 0.7. So this part here is 0.7. Let's normalize this, because we can only compare the probabilities when they have the same z-score. So, z is less than m minus 20 divided by. The usual notation for a normal distribution is mean and variance. In this case, you're given the variance is 9 sigma squared. Therefore, the standard deviation is 3 sigma. Since they have the same probability, the set score must be equal. Three divided by sigma is equal to m minus 20 divided by 3 sigma. Therefore, m minus 20 is equal to 9, m is equal to 29. And this is the end of the question. This is question 6 of the N25 mock paper 1. We have 4 consecutive terms in an arithmetic sequence. You are given 2 pieces of information, and you are asked to prove that there is exactly one set of integers, and find this set. So, if A, B, C, and D are 4 consecutive terms, let the common difference of this sequence be M. We don't want this to be D because it can be confusing having 2 Ds. So I let the common difference equal to M. Okay, so D is equal to A plus 3M, C is A plus 2M, and B is A plus M. You do not have to write this out on the exam. First piece of information, the sum of the 4 terms is 50. So A plus M plus A plus 2M plus A plus 3M is equal to 50. 4A plus 6M is equal to 50. 2. C minus A is greater than 13. Therefore, 2M is greater than 13. How can we use these pieces of information? We know that 2M is greater than 13. That means that 6M is greater than 39. That means that 4A has to be less than 11 because the sum of the two is equal to 50. Thus A is less than 11 by 4. We also know that A is a positive integer. That means that A is equal to 1 or A is equal to 2. If the sum of the 4 terms is equal to 50, that means that 4 plus 6M has to be equal to 50, or in the other case, 8 plus 6M is equal to 50. M in the first case is equal to 46 by 6, and M in the second case is equal to 7. If M is 23 by 3, B is therefore 26 by 3. In the second case, B is therefore 9. We are also given that B is in positive integer, so this is not a possibility because it is not an integer. Thus, M has to be equal to 7. If A is equal to 2 and M is equal to 7, B is equal to 9, C is 16, D is 23. And the only set A, B, C, D is 2, 9, 16, and 23.